examples. Oh, wrong share. Let's go to our examples. And so from here, can I get you to do question, just to start off with, question 1C and E, and let me just get rid of that. So 10 centimeters, so the radius is 10 centimeters and the subtended angle is 5 pi on 6, and 7 millimeters and the subtended angle is 45 degrees.
All right. Uh, 125 pi on 3.
125 pi on 3, perfect. And what's the units for that?
That is in centimeters.
No. What are we finding? The area of the sector.
Right. Square centimeters.
Centimeters squared, perfect.
Yeah. 7. That'll be 49 pi on 8 millimeters squared.
Perfect. That is exactly right. Does that make sense?
Yep.
So now, can I get you to do, so I don't really think anything else there is that useful because it's all pretty much just the same thing. But can I get you to do question 15?
Sure.
And so that should be coming up there, and that should be B, and that should be 12 centimeters, right?
Cool. Yeah. All right. Center of the, okay. 12. Is 15A 5 on 4 radian?
15A 5 on 4 radians. 15A, it asks for it in degrees and minutes.
Oh, right. Okay. All right. 180. $71 37 minutes.
Not quite. So what did you do?
All right. So what I did was I got the radians arc length formula.
Yep.
And I did, so L equals theta radians times the radius. So the radius is 12. So L equals theta times 12.
Yep.
And then the length is 15, I think.
Oh, no. So importantly, that's the length of the chord here.
Yeah.
but L is the length there.
Yeah, so how do you find that?
We don't.
Oh,
So here, let's look at this triangle. So is this a right angle triangle?
no.
No. So we can't use Pythag. Well, we don't know. Theta might be 90 degrees, but we don't know. So we don't know if we can use Pythag.
Mm-hmm.
What can you use for non-right angle triangles? What rules do you know?
Sine or cosine rule.
Yep. And what do we need for the sine rule?
We need an angle, and we need two sides or two angles, and one side or one angle. We need three things in total.
Yeah. So we need two sides, two angles, and one of them has to be missing.
Yeah.
And what about the cosine rule?
We need two sides and an included angle, or we need the opposite. We need the side opposite and an angle and two sides, or we need three sides and a missing angle.
Yeah. So we need three sides and an angle, and one of those components has to be missing, and the angle has to be opposite.
Yeah.
So from here, which rule do you think we'll be able to use?
The sine rule.
Okay, let's have a look. So we've got two sides. That's good so far. We've got an angle. What angle do we have another angle?
We do not.
Could we find another angle?
Possibly using the cosine rule.
Yes. So should we just jump straight to the cosine rule?
Yes, we should.
Yes. So, but for the cosine rule, we need three sides and one angle. We've got two sides and one angle, but do we have another side?
Yes, we have. The
How?
other side is 12 because the radius is 12.
Perfect. So that should also be 12 centimeters because it's still the radius of a circle. So it's the same as the other radius.
Mm-hmm.
All right. So now, how do we use the cosine rule from here?
Okay, so it is the cos theta equals 12 squared plus 12 squared minus 15 squared all over 2 times 12 times 12. And that is 1.3. My calculator's in radians. I need to change it to degrees, don't I?
Depends. Are you doing the inverse cosine piece for it?
Yeah.
Yeah, then you definitely need to change it. And this is what I was talking about, making sure it's in the right version.
Yeah. So 77 degrees and 22 minutes.
Perfect. So that gives us that implies that theta is equal to 77 degrees and 22 minutes, and that is correct.
Cool.
All right. Does that make sense?
All right. Yeah. All right. Now B. Find the area of okay, so that is,
So how would we find the area?
we could use half AB sine C.
Perfect, because that is the area of a non-right angle triangle or a triangle where we don't have the height.
Yeah. So half times 12 squared times sine of 77 degrees, 22 minutes. And we end up with 70.25 square centimeters, 20.26. One decimal place. 70.3.
70.3 centimeters squared? Perfect.
Yep. Find the area of minus segment half by the chord. Okay, so I need to find the arc area and then subtract the triangle area. Or the sector area, sorry. So the area of the sector is half times theta in radians. squared. End up with 97.2 centimeters squared. So minus 70.3, we end up with 26.92 centimeters squared for C.
For C, 26.9 what?
2 centimeters
That
squared.
should be 96 centimeters squared. So
Probably.
find the area of the minor segment cut off by the... So let's have a look.
Must be some rounding in there that I did.
Must be.
Should I? I'll do it again without the rounding. See what I get.
So find the area of the minor segment cut off by the chord. So the chord, the minor segment is going to be this portion.
Yeah.
So we find, what we do is we find the area of the sector.
Yeah.
And then we subtract the area of the triangle.
Yes.
Yes. I would suspect there's rounding errors with the pi because you're working in degrees and minutes. So when you did the pi, you probably, did you round it or did you put it in as pi?
I put it in as pi, but then that probably got rounded to like about 9 decimal places, like a couple times.
Yeah.
So yeah. All right. So D. Area of the major segment cut off.
So the major segment now.
Right. So that's the rest of the circle.
Yeah. So and if we have our chord here, the major segment is going to be all of this.
Yep.
So how would you find that?
Okay. So the area of the circle is pi r squared. So pi times 12 squared. And that's 452.389. So 39. And then minus the minor segment, which was 26.6 something. And we get 425.8 roughly.
Roughly, the round is still off. It should be 425.43.
Right, yeah, that's because I used the my the wrong minor segment area.
Yeah. All right.
Yeah.
Does that make sense?
Yeah.
All right. So now I will get you to do. I will get you to do 16. So that's going to be That's going to be 100. All right. So can I get you to work through 16?
Yeah. got 14.98.
14.98. That's perfect.
Cool.
Perfect. Does that make sense?
Yep.
All right. So I think now let's go over some of your topic tests. So, because that's basically it. That's trig done. So the last topics were radians, area of a sector, length of an arc.
Yep.
So overall, the last few sections are what are radians, how to convert to and from them, and where are they used.
Right.
Does that make sense?
Yep.
So from there, that pretty much sums up radians. So from this point forward, you'll pretty much be using radians all the time.
Right.
When you're doing calculus, when you're doing all sorts of other topics later on involving trig, we basically just work in radians because they are the
Right.
preferred version, essentially. We can use them for easier formulas, and that's what sine, cos, and tan were originally designed to be used with. So that's why we use radians.
Right.
All right. But let's walk through some of this stuff. And you can see the screen okay?
Yep.
So let's do some fun ones. So can I get you to do, let's find a good bearings question because I know how much everyone loves doing bearings. Doesn't look to be anything too bad, to be honest. Oh well. Let's do question 20.
All right.
It shouldn't be too bad, but just to start with, and then we'll move on to one of the challenge exercises and then probably finish up for today.
Yeah. And this is just in degrees, not radians? Or
This is just in degrees.
All right, cool.
Unless it says in the trig topics, unless it says radians for now, just use degrees. But once you get into year 12, once you start using trig outside of the trig topic, you're basically just using radians.
Right. I got 51 degrees and 40 minutes.
51 degrees and 40 minutes is perfect. Does that make sense?
Yep.
All right. Let's go to the challenge exercises. So, can I get you to do question 3?
Sure.
Oh, actually, you can't really see the end of question 3. So I might get you to do question 5.
Yeah. 4.8. 93 meters. Due south of the base of the chapel. All right. For A, I got 65.12 meters.
Yep, 65 meters works fine for that because it says to the nearest meter.
Right. And for B, I got 27 degrees and 42 minutes.
Perfect. Does that make sense?
Yeah.
All right, so no, I guess you had no real issues with that one. What about question? Let's keep going. Let's this. Oh. What about question 10?
Sure.
Actually, a little bit more related to what we've been working on.
Yeah.
12.
Sure. Okay. So is it meant to... Oh, I guess it doesn't matter if it goes to the end of the clock, does it?
What do you mean?
No. I was just wondering how much of the actual clock the hour hand filled up, but that doesn't matter at all for the
No,
questions.
it doesn't. Not for this one because they're giving you the length of the clock hand.
Yeah. The length of the arc. Okay. My hours. All right.
How are you going?
Good so far. For A, I got 10 pi centimeters.
10 pi centimeters. 10 pi centimeters. Perfect.
And almost finished B. 12 squared times 1/2. I got 24 pi square centimeters for B.
Yeah, that's correct.
Cool.
Does that make sense?
Yep.
All right. So we might leave it there for today.
Sure.
'Cause, yeah, we just finished trig. So there's not really much else to go through for trig.
Right.
Now, for homework, I'm going to email this test yourself and the challenge exercise. Actually, do you have a textbook?
Maybe. So is it the Cambridge one? Which one?
Oh, this is Margaret Groves. So you probably don't then.
No, I won't.
Okay. So for homework, I'm going to send this to you and I'll get you to finish the test yourself and the challenge exercises.
Right.
Just making sure that you understand them. Particularly do the challenge exercises first and then go back and do the test yourself section.
Okay.
And then, yeah, and then next week we'll start the next topic in your syllabus.
Cool.
And get you well ahead of your class at that stage.
Yeah.
But that being said, before next week, if there's any questions you've got from class, please message me.
Yeah.
Or we can go through them at the start of this lesson. But importantly, if you've got, when you do your homework this week, make sure you send me the solutions beforehand.
Yeah.
That way, I can mark it beforehand and then we can go through it.
Yeah.
All right.
All right.
In that case, I will see you next week.
Yep.
Enjoy your week and enjoy your time at home.
You too.
All right. Bye.